Booth's algorithm. So for that is the multiplication algorithm. The multiplication algorithm. So I think yesterday I have sent some uh, class materials. So this one. Have you received this video link? Yes, say anyone, yes. Have you received the yes?
Yes, sir.
Yes, sir.
So I will also explain the concept, but you also go through because the videos are already created by me from last past couple of years back. So you just go through that, and in the Booth's algorithm, what we study is Booth's algorithm means it's a high performance multiplication algorithm. We call it as the high performance multiplication algorithm. Okay. Uh, So like for example, in the computer it performs the multiplication. Computer performs the multiplication. Uh, so that is by using the Booth's algorithm approach. Booth's algorithm. So this is also very important for your examination point of view. You will get a 8 marks questions. Booth's algorithm for a high performance multiplication. High performance multiplication. This is the normal method, normal conventional method. Whatever we do in our daily life, the multiplicand and multiplier. To multiply the two numbers, you require to multiply it, you require two numbers. One is multiplicand and another is multiplier. So multiplicand, it's a 10. That is a base. The 10 is a decimal number, and the corresponding binary number is 1010. And the multiplier is 30. Their corresponding binary number is 410. So this is the binary for 10 and 30. So this is the way the partial products. This is the conventional method or pencil paper method that we use for the multiplication. So this zero with this zero into all zero zero, then this one to zero one one the one 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 zero zero one. So these are all called as partial products, and this you know from your childhood how to perform the multiplication. So 10 into 30. So we got the answer as this is 300. So this is the right. Okay. For conventional method, 10 into 10 into 30, we will get 300. So this method, it will work for the this number 10 into 30. 10 into 30 plus 10 into plus 30, you will get plus 300. But the drawback is that if suppose one of the number is a negative, if one of the number is negative, if one of the number is negative, then this conventional method will not work. This pencil paper method will not work for the negative operands. For negative operands, it will not work. So you can check also. So in computer multiplication, what you have to do, how it represent the number is the positive number. Okay, so for positive number, it's a plus 10 means it represents the binary 1010. But in case of this minus number, minus 30, so in case of minus 30, what it does, minus 30 means the computer will take 2's complement of the number. 2's complement of the number. So minus 30. So minus 30 means how you have to calculate is, so for minus 30, first you have to calculate what is plus 30. Plus 30. So plus 30 means, so this is the binary for 30. 4 times 1, 0. You can do in a paper the binary for 30. Okay, here 2 raised to the I can show you cross check. 2 raised to 0, 2 raised to 1 position, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 4, 2 raised to 8, 2 raised to 2, 2 raised to 4, 2 raised to 3, 2 raised to 2, 2 raised to 1. Just I'm cross checking it. So 14, 16, so 30. So this is the binary for 30. Okay, this is the binary for 30. If I add the 0, so if I add 0, then it becomes plus 30. It becomes plus 30. So this is for the 30. If I add 0, it's a plus 30. Now what I want? Minus 30. So you have to take the 2's complement. 2's complement 1, 0, 0, 1. This is 1's complement. Add 1, 0, 1, 1, 0. Okay. So this is your number. Means the while performing the any division operation or multiplication operation for signed number, the computer will consider for this negative, for this signed number, for signed number minus 30 means it will consider in a 2's complement form. Computer will consider which form? 2's complement form. 2's complement form. So this is plus 10 minus 30. And when you do the normal conventional method, these are partial products. How many? 1, 2, 3, 4, 5, 6 digits are there. So you will get 6 steps. Yes. And the result, whatever you get, the result is also in the 2's complement form. The result is also in the 2's complement form. And here we get, just to cross check 2's complement, the result will be in the 2's complement. And to cross check that, again you take the 2's complement, you will get the 192. But plus 10 into minus 30 means it should be minus 300, the correct answer. But here how much you are getting? 192. So this is wrong. This is wrong means this conventional method will not work for negative numbers. Conventional method, it will work only for the positive numbers. Positive numbers means plus 10 into plus 30. But it will not work for the negative numbers. I hope you understood. Uh, yes, any doubt? So any doubt with respect to this? Mention in the chat. Yes, Abhishek.
Yes, sir.
Any doubt?
No, sir.
Uh, so, so in the normal method multiplication, in the normal method of multiplication, it works for the only positive numbers. It works for only positive numbers. But for negative number, what to do? For negative number, you have to use the some other approach. So that is, we go for Booth's algorithm. That we go for the Booth's algorithm. So you know, I think you came to know what is the importance of Booth's algorithm, Booth's multiplication algorithm in a computer. Okay, what are the drawback? It won't support for the negative numbers. Negative for negative number, it will not work. You can check also. You can take a minus 10 into 30. Minus 10 means you have to take the again 2's complement. 2's complement you have to take, and the result will also in the 2's complement form, and you have to cross check. Okay. So this concept that I have mentioned in the first video, whatever I sent yesterday link. So in that uh, I have explained clearly how we can perform the multiplication, or how we can take the ones complement, two's complement. Okay, so the approach, the for that approach for negative or signed number multiplication, the approach solution is that Booth's algorithm. So Booth's algorithm for signed number multiplication. Booth's algorithm for signed number multiplication. Signed number multiplication. Signed number multiplication. Okay. Signed number multiplication. It equally works well for the positive numbers and negative numbers. So for that, first you need to understand the hardware. So this is hardware diagram. Okay. So you may get a question in the, this is the hardware implementation of Booth's algorithm. Hardware implementation of the Booth's algorithm. So you may get a question in the exam also. So here multiply. So for just one thing, simply I will within a simple word I will explain the concept for the Booth's algorithm, how it works. Okay. Uh, for multiplication, you require two numbers, right? One is multiplicand. You require two numbers. One is multiplicand, and that multiplicand you store in a register called as B register. Okay. You store in a B register. What is multiplicand value? For example, 10. So 10 where you store? You store it in a register that is called as B register. This overall diagram is a hardware implementation, how the performs its multiplication, how it performs the multiplication. It's a hardware implementation of Booth's algorithm. So in multiplicand, you store in a B register. So you require one more number. Okay. You require one more number, so that is multiplier. That is multiplier. To perform the multiplication, you require two numbers. You require two numbers. So one is multiplicand and another is multiplier. Okay. So multiplier in Q register. This is one register. This is one register. So that is Q register. So one number in B register, that is multiplicand value, and multiplier in the Q register. So there are two numbers, multiplicand and multiplier. Okay. And this multiplication in Booth's algorithm, we use a method called as shift, like the arithmetic shift, add and subtract means we use shift operation, we use addition, subtract method. We use shift, add and subtract control logic circuits to perform the multiplication. For example, 2 into 3. So how you perform the 2 into 3? One is that perform the addition 3 times of 2. So the result is 6. So 3 into 2, 6. Addition method. Or one more is perform the addition of 3 2 times. So that is 6. So this is the normal method, addition method. Okay, similar to that. So here the circuit is designed to perform the multiplication. So you store one data, that is multiplicand in B register, another value in the Q register, and you use shift method, addition and subtract control logic circuits. Then here we use one more register, that is accumulator, A register. Okay, A register. Initially the value will be in the multiplicand and multiplier. Okay, and to perform the right shift, to store the result and all, we use accumulator register. So total 3 register and one more, that is q minus 1 bit register. Q minus 1. Q minus 1 bit register. So totally how many bit registers we are using? One is multiplicand B register, multiplier Q register, and there is an accumulator to store the value and all, and Q minus 1 bit register. So total 4 registers. So in hardware implementation of Booth's algorithm, it consists of n bit adder. Yes, n bit adder means to perform the operation. This is n bit adder. Okay. So n bit adder means how it performs means you can see in the diagram. See here, this n bit adder, it receives the input from this from multiplicand. You will receive the data, and also you will receive the data through this logic circuit. Okay, through this. So here you will get based on some operations are there that we will discuss, the addition or subtract, enable and all. So that we will discuss. Hmm. So n bit adder means it take the data from the it take the data from multiplicand and multiplier. So n bit adder is very important. The role n bit adder. N bit adder. So it is very important. If you don't know the concept, then you won't be able to perform the multiplication. You need to understand what this hardware implementation. Okay. So in Booth's algorithm hardware, it consists of what? It consists of a n bit adder. It consists of n bit adder, then shift operation, shift circuit, add and subtract control logic, and four registers. Four registers are very important. Four registers: A accumulator register, B multiplicand value is stored in the B register, then Q multiplier, and Q minus 1 is a single bit register. Okay, and multiplier and multiplicand are loaded into the multiplier Q register, multiplicand B register. Simple thing. So in hardware implementation of Booth's algorithm, what are the contents are there? A register is there, accumulator, then B register for multiplicand, Q register for multiplier, Q minus 1 a single bit register, single bit register. So these are about the registers. Along with that, there is a n bit adder means to perform the addition, n bit adder, then shift operation, shift, then add and subtract, shift, add and subtract. So this is the your hardware implementation of binary algorithm. So I will explain once again. Uh, to perform the multiplication using the Booth's algorithm, using Booth's algorithm, you require two numbers. So one is multiplicand and multiplier. So multiplicand you store in the B register and the multiplier in the Q register. And to perform this, we use a shift method, addition, subtract logic circuits we use. So for this we use n bit adder addition. Okay, n bit adder to perform to perform the addition of the values from the B register. and the values from the multiplier. Here it will go. Okay, so actually it will the bits will go from this side. Okay, so for that we use shift method, right shift, add, subtract logic. So first basic you understand what are the registers and all. For that one more flowchart is there. So in the flowchart you will understand what exactly the how it both algorithm it perform the operation and bit adder, and it store the result in a this accumulator, store the result in the accumulator. So totally it requires what it requires multiplicand register, B register, then Q multiplier, one accumulator register, then Q minus one register. Okay, they are main very important, and it performs the order shift, add, and subtract operations. Shift, add, and subtract operations. So so tomorrow we'll discuss clearly this diagram, the flowchart. So Booth's algorithm means how it flows. First, this is the initialization, of accumulator, initialization of single bit register Q minus one, multiplicand value, and multiplier register. So first we initialize, like for suppose for example, if we assign the multiplicand 10, multiplier minus 30, we'll initialize, and accumulator initially it is initialized to 0, and Q minus 1 also initially 0. This is initialization. Then after that what happens? You have to check the condition Q naught and Q minus 1 register. Okay, Q means multiplier. So multiplier means how it stores? It stores in this form. Like suppose if it is 5 bit, then Q minus 1. Okay, so this is Q naught, Q minus Q naught, Q1, Q2, Q3, like Q register bit position, and this is separate Q minus 1 bit position. Tomorrow we'll discuss that how it. So it check the condition, it will compare the value, it compare the value of Q naught and Q minus 1. Okay, because in the hardware implementation you can see here in the hardware how the accumulator register, and beside that multiplier register Q naught, Q1, and Q minus 1 bit. So we are comparing these two bits. Okay, we are following the hardware implementation. Okay, Q naught and Q minus 1 we are comparing Q naught value and Q minus 1 value. So this is the hardware diagram, and this is the flowchart. Okay, so here what then after we are comparing the Q naught and Q minus 1. Compare, then after compare, if suppose if both the bits are 1 1, means Q naught is 1, Q minus 1 is 1 1, or if it is both are 0 0, means both are same, then we need to perform arithmetic shift right operation. Arithmetic shift right means like this is accumulator, this is multiplier, and this is a single bit register q minus 1. This is multiplier. Multiplier is q, and this is accumulator. So what we do here, we'll shift, right shift, arithmetic right shift a, content of a, content of q, content of q minus 1. Suppose if it is 0 1 1 0 1 1 0 1, suppose this is the case. But here so this is condition, means you suppose this is 1. Okay, if both are same, q naught and q minus 1 both are same, or both are 0 0, or both are 1 1. So what is the operation? Shift right. Right shift means here you have to shift to the 1 bit position to the right. So here this will be as it is. If it is 0 means 0, this will shift to 1 bit position here 1, and this will shift to here, and this 0 will go to here, this one will come here. I hope you are understood. Right shift, you have to perform the right shift of content of a q minus 1. Then suppose if the condition is 0 1, this is the condition for just now we did for the if both are same. Suppose if it is 0 1, q naught value is 0 and q minus 1 is 1, then what to do? You have to perform a plus b operation, means content of accumulator, content of multiplicand, you have to add and store it in the accumulator register. After that you have to perform the same operation, arithmetic shift. Okay, then for say another condition, if it is 1 0, if it is q naught is 1, if it is 0, then you are required to perform the a minus b operation, content of a, content of b, and then you have to perform the arithmetic shift. So total 4 conditions. If both are same, 1 1 or 0 0, only shift operation. If it is 0 1, perform a plus b operation. If it is 1 0, a minus b operation, then perform shift operation. Okay. So you need to understand this flowchart is very important until the completion of the number of steps. In this way we have to perform. So in the tomorrow lecture we'll discuss in detail about how we can perform the multiplication of a number.